The Jake Brake compression engine retarder is a cost-effective means of providing additional slowing power to maintain vehicle control. The Jake Brake is not a substitute for the service brakes. It is a hydromechanical engine retarding system that uses the diesel's own power to help slow and control the vehicle. The force that moves you forward is used to hold you back. With a Jake Brake, up to 100%, and in some cases even more, of the engine's rated horsepower is available at the drive wheels. And that's a lot of slowing power working for you. The more you use the Jake Brake, the less you use the service brakes. They stay cool and ready to respond with maximum stopping power whenever needed. Of course, the Jake Brake offers many other benefits. It can double or even triple service brake life. You can save trip time with a Jake Brake. It permits higher speeds within the posted limits under full control. The Jake Brake saves wear and tear on your tires, on your engine too. And because it provides better road control, it saves wear and tear on you. You'll be glad to know that operating with an engine retarder actually makes driving easier. The Jake Brake uses engine oil for hydraulic fluid, so be sure to let the engine warm up before proceeding. Now, let's take a look at the driver controls. The dash switch turns the system on and off. Normally, it is left in the on position whenever you're driving. Most Jake Brake systems are equipped with a multi-position progressive braking switch. This feature permits selecting the number of brake units required for specific conditions. The type of switch used depends on the engine make in the vehicle. The clutch and throttle switches are activated automatically. The Jake Brake only operates in a no-fuel position. So when your foot is off the clutch and you remove your foot completely from the throttle, the Jake Brake goes into action. It will also remain in operation when the brake pedal is depressed, giving you the combined slowing power of both systems. When you reapply pressure to the throttle to accelerate, the Jake Brake is instantly deactivated. The brake system is also de-energized when you depress the clutch to shift gears. Never use the Jake Brake for gear shifting. It could cause abnormal stresses and shock, and may lead to engine failure. At the end of your run, be sure to turn the Jake Brake off. Now, a quick review of what we've covered so far. First, always let the engine warm up. Then turn the dash switch on and keep it there for the duration of the trip. To activate the Jake Brake, just take your foot off the throttle with the clutch pedal out. Remember, the Jake Brake stays on when you apply the service brakes. To deactivate the system, depress the throttle. The Jake Brake also deactivates when the clutch pedal is depressed. And never use the system for gear shifting. System operation is similar with an automatic transmission. It's energized or de-energized as you step on and off the throttle. However, a pressure-sensing switch de-energizes the system at low engine speed to prevent engine stalling. As mentioned earlier, just about all Jake Brake installations are equipped with progressive braking. This feature permits selecting varying numbers of brake units to meet load and road conditions. System design allows switching from one position to another, regardless of whether the brake is energized or de-energized. Two types of progressive braking systems are in use. Yours will depend on the engine make and configuration. Basically, there is a 3-position switch model and a 2-position high or low type. The 2-position system incorporates all functions in a single dash switch. The retarder is either off or in the high or low retarding position. It is used on all Jake Brake systems except for the Cummins NT engine applications. In the low position on a 6-cylinder Caterpillar or Mack engine, 3 cylinders provide slowing power, about half of the total available. In the high position, all 6 cylinders are utilized, producing 100% of the Jake brake's retarding power. The same 2-position system applies to the Cummins and Detroit Diesel V series. In this case, low activates one bank of cylinders, and the high position operates both banks. On Cummins inline NT engines, 3 brake housings each control 2 cylinders. In addition to the standard on-off dash switch, there is a separate 3-position progressive braking switch. In position 1, only 2 of the engine's 6 cylinders are providing slowing power. In position 2, 4 are utilized, about 2/3 of the retarding available. And in position 3, all cylinders are working to slow and control the vehicle. What position is the right one for normal conditions? That depends. If the driver is running with a light load on flat, open stretches, he should use the low or number 1 or 2 position. With a heavier load on a dry surface, the progressive braking switch should be in the high or number 3 position. You should always be aware of braking switch position so that you can move it up or down as road or load conditions change. Let's look at the benefits that make a Jake brake indispensable for a wide variety of driving situations. For example, you're rolling on an interstate and want to slow to an exit speed of 35 miles an hour. Instead of pumping the service brakes, just take your foot off the throttle and the Jake brake takes over. This keeps the service brakes in reserve, preventing heat buildup and dangerous brake fade. There's a stop sign ahead. Again, just let up on the throttle and the Jake brake will slow you down. Then apply the service brakes to come to a full stop. Now you're descending a grade. The correct use of the Jake brake for this situation requires an understanding of control speed. Control speed means a constant speed at which the forces pushing a vehicle forward on a grade are equal to the forces holding it back without using the service brakes. In other words, control speed is the rate at which you can safely descend the grade, with the Jake brake doing 100% of the slowing job without using the service brakes. Since the Jake brake is most effective at rated engine speed, gear selection is very important. Maximum retarding power is obtained when you use the lowest gear possible without exceeding recommended engine speed. For example, depending on road and load conditions, you may be able to safely descend a 6% grade at 10 miles an hour without a Jake brake. However, the Jake brake may allow you to descend the same grade at about 25 miles an hour and still maintain control. Under some circumstances, you may want to descend the grade faster than control speed. Just select a higher gear. However, this may require using the service brakes to keep your vehicle under control and prevent engine overspeed. Frequent use of the service brakes may cause them to overheat and reduce stopping ability. The result can be brake fade, and as you know, that can be dangerous. In other circumstances, you may want to descend slower than your control speed. To do this, select a lower gear that will not overspeed the engine. You may also have to move the progressive braking switch to a lower position. This will reduce the slowing power of the Jake brake and let you maintain the desired speed. As a general rule, to maintain control speed, estimate which gear you would use to climb the grade. Usually the same gear can be used for controlled descent with a Jake brake. Of course, like any product, the Jake brake can be abused. Using the previous example of descending a 6% grade at 25 miles per hour doesn't mean you can take the same hill at 60 miles per hour and maintain complete control. Don't exceed a safe control speed. Make some practice runs to learn how much slowing power the Jake brake can provide, and don't abuse it. Before beginning a long, steep descent, always check to make sure the retarder is operating correctly. Briefly lift your foot off the throttle, and if the system is operating correctly, you'll feel the retarder go into action. Using a Jake brake means you can descend grades at a higher but safer control speed, providing momentum for the next uphill grade. This capability reduces gear shifting, puts less demand on engine power, and saves wear and tear on you. Now let's review the important points of using the Jake brake under normal, dry pavement conditions. If you're running with a light load, leave the Jake brake in the low or number 1 position. For a normal load, put the retarder in the high or number 3 position. The Jake brake can be used at any recommended RPM you use to pull the load. To provide slowing power, just remove your foot from the throttle. Apply the service brakes if more braking is needed quickly, or to bring the vehicle to a complete stop. Remember, the system stays in operation when the brakes are applied. For maximum slowing power, use the lowest possible gear without exceeding recommended engine speed. Generally, the gear you use to descend a grade at control speed will usually be the same gear you would select to climb the grade. You can exceed control speed by selecting a higher gear. This is not recommended, as it causes greater tire, brake drum, and lining wear, as well as the danger of overheating your service brakes. To go slower than control speed, select a lower gear.